everybody, this is DLL Cool J coming at you from Arch Cloud Labs, and today we're going to go ahead and generate some shellcode with a subcomponent of the Radare2 or R2 framework called Radare2. And I have the man page pulled up here, and we see that Radare2's front end for RAG will, or RAG2, will compile programs into tiny binaries for 32-bit, 64-bit, and ARM architectures. Effectively, what we're going to do here is write some very basic C code, compile it down, grab the shellcode aspect of that, and actually slide that right into a shellcode runner that I have on my GitHub as kind of an example runner to play with. It was referenced in the Ghidra extracting shellcode video. So this is a nice kind of complementary video to that. So you can generate some shellcode, use it with the shellcode runner, and then use Ghidra to extract it. So with that being said, let's just go ahead and dive in. And if you don't have Radare2, definitely go over to the GitHub to grab the latest version. Most repos tend to be stale with the pace that the project moves. So move on over to their GitHub repo, and they have a couple pretty basic install scripts, and maybe I'll do a video on that at a later time. But with that being said, let's just go ahead and dive in. So I've got a couple things going on in my little project repo here, but first and foremost, let's go ahead and take a look at the C code that we want to convert into shellcode to execute through our shellcode runner. So go ahead and we'll open up our favorite text editor, Vim, and see that we have a super basic program here that effectively what we're going to do is go ahead and cat flag.text via the execve syscall. Nothing fancy, no libraries are getting imported, we're just, straightforward cat flag.text. So we're going to go ahead and shift now and look at the Radare2 component of Radare2 and how we can use this to actually generate the shellcode for the shellcode runner. So if I go ahead and just execute Radare2, you're going to see a plethora of command line options. Depending on what you're trying to achieve, definitely take the time to look at these. A really key component just to put off right off the bat, if you're doing this on Mac, please make sure that you're using the appropriate formats, or the appropriate architectures for the Mako outputs versus like an ELF output. Additionally, make sure that you're paying attention to the output format that you want your shellcode in. So today we're going to use, we'll show an example of the raw versus C, but you also might want it to just create a small ELF binary that just does that, maybe for Python output, maybe you're fiddling around with JavaScript, hope not. But either way, there's a bunch of different ways that you can get the shellcode outputs, and that's just kind of what I'm trying to show here. It's definitely worth some time to read through the manual page and understand all your command line switches. So with that being said, I'm going to go ahead and skip the line here because I actually have a corresponding blog post that goes into some of these command line switches that show you exactly what's going on underneath the hood. And if you're interested in that, check out this project page that should be going across the screen right now. But for right now, we're just going to go ahead and generate the C output, and I'm going to do that via rag2 -f for C because I want the C output, -o for payload.h, that's going to go into my header file, and then shell.c being the program that I want to generate shellcode from. So let's go ahead and run that. And that went ahead and created our payload.h. Excellent. So if I go ahead and cat payload.h, I see that I have a lovely header file here with a buffer size of 184 bytes, a const uint8 array, and this is the shellcode that corresponds to that cat flag program that we looked at a minute ago. Fantastic. Now, what would happen if we go ahead and switch out to the C output with, say, raw? Well, oh, did I actually? Oh, my mistake. I still outputted it to payload.h. So what would happen if we go ahead and just do a raw output of the shell.c? Well, sure enough, you get that same byte array, but without actually being an array. You just see like the raw bytes get printed to the screen, and you have to go and do something from that. Well, that's no fun. And that's why it's super handy that we can go ahead and have this get generated in C. if I remember to do this appropriately, and see that we have the same output. So even just looking at the first few bytes, E9, hex E9, OB0000, etc., we go up top and it sure is the same output. So going back to generating this to be into our header file, let's go ahead and look at our payload.c component, which is actually going to be the shellcode runner itself. And I'll go ahead and split this like this, so we can just have both pieces on screen at the same time. So pretty dead simple program here, and again, this is available in my GitHub, and it's referenced in the Ghidra project as well, or the Ghidra reversing video as well. We go ahead and we create some executable memory, and then we go ahead and basically just do pointer execution on the buffer that has our shellcode. So what this is doing under the hood is saying, hey, this buffer, let's treat this as a function, and we're going to call this exe shell, right, like execute shell, and we're just going to go ahead and run it. So at the end of the day, a register gets pointed to all of this shellcode, and it gets treated like a function, and it just gets executed. And we're going to go ahead and actually leverage Radare2 to take a look at what this looks like in the disassembled format. So with that being said, I'll go ahead and close out of this, and I'm going to generate, whoops, oh my goodness, and I'm going to generate my payload really quick. So we have this a.out file, so let me go ahead and pop that into Radare2. So first, let's go ahead and analyze the binary, and you can do that with 3 A's from the Radare2 little command prompt here. And if you're ever curious about what these utilities do, you can always just add in a question mark in the Radare2 command and then get a bunch of data shown back at you. So this can be, you know, to see vtables if you're doing stuff with C++, so you can analyze functions, you can see opcode, manage classes, see bytes, etc., etc. There's a lot to go over here, and you know, definitely beyond the scope of this video. So let's go ahead and we ran A 3 times, which effectively that will do for us is show auto-name functions and also show symbols and etc. So let's go ahead and with that, let's list the symbols. So just an IS, I for info, S for symbols. You can do a capital S for sections. But here we see right at the top, there is a main function. Excellent. Well, that's because I didn't strip the binary of any of the symbols to make it a little bit easier for this to go around. So let's go ahead and search to that main function. And then with this, we're going to go ahead and print out the function itself. So PDF. And here we see the main function's underlying assembly code. And we have some space getting cleared up at the top here, variables, etc. We see our call to mprotect that we looked at a second ago. And then we see this object buffer getting copied over into RAX. We see a couple moves happen, and then eventually a call to RDX, which eventually is the payload of the obj buffer, which is our shellcode, where it ends up. So this goes back to that, let's just execute this as a function piece. We see a call to that function being just our big old buffer shellcode. So let's go ahead and actually seek to that buffer. And a quick Radare2 piece here is we can go ahead and do obj for object, hit tab a couple times, and see this get auto-completed. You can also do the same for like string, so str dot and then whatever the string would be. And you know, spoiler alert, we're seeing some flag.txt and some bin cat, that kind of stuff. So like obviously that, you know, cat flag piece that we had in our payload, that's showing up here. But let's go ahead and go to that buffer. And then again, let's just go ahead and print the hex of that. So that buffer that it's referring to, that's getting copied over and moved around and ended up in RAX, sure enough is the same shellcode that we have stored in our payload runner. And we can go ahead and verify this. If I split the tabs here and open up payload.h, and once again we see that E9, OB0000, etc. Let's go over to 66. And sure enough, E9, OB00, etc. There you go. So with that, we can now go ahead and actually execute our program. hey, wouldn't you know it, flag.text links over to a blog post where I kind of dive a little bit deeper into the Radare2 functionality itself, or excuse me, the Radare2 functionality of how this payload gets generated. So that's all for today, just a kind of quick rundown on a blog post I wrote a couple weeks ago. This is the first post of the year. Like, subscribe, comment below, let me know what you think. From my lab to yours, this is DLL Cool J signing out.